Hess's law states. Come on, should be able to rattle it off by now.
Wait, enthalpy change is independent of the route taken.
That's what you should be able to do. Enthalpy change is independent of the route taken. I'll just leave that up. The two examples that we gave when we were doing, that's all out of sync. I don't know what Microsoft has done to my precious PowerPoint, but it doesn't look quite right, does it? Oh God. What could go wrong? Let's try that. When we were looking at the two examples that we're going to use of Hess's law, for formation we had a common set of reactants down here, the elements, which can make both A and B, and the alternative was where we have a common set of products and we can make A and B into those products. That's the one we used with the copper sulfate required prep. Yeah? Okay. So enthalpy of combustion is going to be that style of example. Okay, so enthalpy of combustion. So we had a kind of long definition for enthalpy of formation. Enthalpy of combustion is going to be very similar. What was enthalpy of formation? Somebody want to rattle that off for me? When 1 mole of substance keep going. Is formed from the elements, so we're not going to be forming anything, we're going to be burning stuff, is completely combusted or completely burned in oxygen. Just to clarify that, I don't think you can burn things in anything else other than oxygen. What comes next in our enthalpy formation? All substances being in their standard states. Last bit.
Standard conditions.
Standard states under standard conditions. Okay. Okay, so hopefully this is going to be a bit more reasonable than the formation thing. Do you remember quite a lot of our formation reactions can't possibly happen? You can't make ethanol by reacting graphite with hydrogen and oxygen, but we can burn things. So could you write me an equation that has the enthalpy change of the standard enthalpy of combustion for ethane, please, C2H6. Write me an equation that has the standard enthalpy of combustion of ethane. Would you like to keep going? Is that Matthew?
Yeah.
Do you want to keep going?
What do you mean?
Help me write the equation.
Oh. So 2C2H6 plus 7O2 arrow
Goes to is how we pronounce the arrow.
4CO2 6H2O.
Okay, we'll definitely need some state symbols to indicate that everything's in standard state. Sorry, I was on the wrong one.
CO2 is a gas.
CO2 is a gas.
H2O is a liquid.
H2O is a liquid at room temperature.
O2 is a gas. And then ethane.
It's a gas as well. Okay, right, what's wrong with that? I'm just going to go to our back corner over there. What's wrong with that equation? It's correctly balanced. State symbols are right. Products are right. But it doesn't represent the standard enthalpy of combustion of ethane, because it has to be 1 mole of substance. So what do we have to do to that equation to make it 1 mole of substance?
Divide it by 2.
Divide it by 2. That means that it's not going to be 7 in front of O2, it's going to be 7 over 2. So you might remember me saying sometimes we're going to have to use halves in our balancing. Well, this is another occasion where we need to use halves. So that would represent the standard enthalpy of combustion of ethane. And I thought I had that written down somewhere. Minus 1560 kilojoules per mole. What do you notice about that number? I hit play again. What do you notice about that number? Combustion. Right. Does it have to be exothermic for combustion?
Yeah.
Yes. You cannot burn things and have them get colder. Right. So delta HC is always going to be exothermic. Delta H is always going to be a negative number. That will become quite important when we're doing our calculations later. In fact, it's already come up, hasn't it? We already had that situation when we were doing the copper sulfate, the anhydrous copper sulfate, and the temperature went up. So you did all your calculations. At the end, you just put in a negative number because you know it's an exothermic reaction. You saw it get hotter. So we're going to have to remember that. And for a fuel like ethane, I don't know if ethane's used much as a fuel, but it could be, it's going to be a fairly big negative number. Because that's why it's a fuel, right? If it didn't give out lots of heat energy, we wouldn't use it as a fuel, because that's what we want fuels to do. We want to, heat up our radiators and our houses and our bath water and so on. Okay, so let's just do another one just to check you're following this. Can you write a balanced equation that is the enthalpy of combustion of, standard enthalpy of combustion of ethanol, please? If you burn alcohol, you're very rarely going to get liquid water produced. If you think about, if you've got a gas fire or a gas cooker, you might get condensation on the windows, but it's not going to come off from the heat in liquid form because, it's hot. Two CO2 gas, 3 H2O. Liquid is what we write. Okay, well, we will carry this on. We'll get on to using delta HC for calculations next time.